Okay, so on this specific problem, I purposefully made it much worse than what I actually gave you. Yes? Okay, there we go. All right. So, what is doing this? The Y is doing that. I love it. Cool. So there was a little bit of cross the wires. The streams got crossed. It's not good unless you're trying to return Zool to their home plane, but don't cross the streams. So this is what Y is doing. So I can immediately just do this. Cool. As Y does that, what is X doing? Yeah, so the next thing people did was you drew a line like this. Does X equal 7Y have a big slope? No, because what is it really? Yeah. So, and when I say what is it really, I just mean what is it the way that we normally look at it, right? So the next thing is this line should be really sloped low. So I've got my Y is going from 0 to that, and my X is going from 0 to 7Y. So a lot of you guys had a picture like this, which is fine. I didn't need to figure out their intersection here necessarily because I wasn't asking you to flip the order of integration. Some of you guys flipped the order of integration, and I felt really bad for you because never do that unless I ask you to, or unless the original integral is impossible to do. Yes? Now, those of you who did this integral, this happens so often with the problems that we encounter in class. The very first step made the next step a u-sub. That happens especially when you notice the inside of your function's got like a y squared and the outside is nothing. You're like, I'm missing a u-sub piece. I probably am going to pick it up when I do the first integral. Yes? Okay, maybe. Now, real quick, can anybody tell me what that point is, just in case I wanted to know what it was? I mean, what's x? 7y, bless you. So at that point, x would be 7 times the cube root of 4 over pi. Yeah. So some of you guys got that. You didn't need to. If you didn't write that down, you were fine. But if I needed to switch the order of integration, I would need to know what that was, right? Now, one really good smart thing to do is shade the region, because there's a lot of stuff going on here, and I don't know if you know which region you're talking about. Some of you guys, of course, shaded this one. Now, how the shit did I figure out that it was this kind of like upper triangle? How the hell did I know that? Yeah, so y is free. Oh, you can just, I'm just gonna go. X is kind of like constrained. X, so for any given y, and dear God, this is such a key step. This whole thing is weird as shit. And part of it is 3-dimensional. And that is not easy to think of, and it's not easy to draw. So whatever you can do for yourself visually, you do it. So this is 2-dimensional. As y does its stuff, for any given y, what is x doing? X is starting here and going there. Yes? Do you guys follow? You want to do this for yourself. This stuff is not like intuitive. You can't just draw it and know right when you see it. Hell no. Shit no. So therefore, that's why I shade here, because x is going from 0 to the wall. And what is the wall? X equals 7y. That's why it's not the lower triangle. Yes? Okay. I like it. So this isn't just a bunch of like, dear God, let me just guess. It's got to be some piece of this thing. You can literally, after you shade, you can kind of double check and just make sure it does. If I do with the outside variable and pick one of those, so if the outside variable was x, I would pick it and then I'd say y goes from this to this. That's the limit, so that should happen on the y. In this case, the y can do whatever it wants. I pick one of those and I say that x goes from here to there. I better see those limits on x's integral. Does that make any sense? Somebody just moved. Okay. Yes.
So y is free because it's on the outside?
It's just it's just constants, right?
Yeah.
So it gets to be those things, but then the inner interval's got to be more specific, so I only slice out that wedge, right? This little dude. So can you, if we had to, we could switch these limits. Then x would go from 0 to this. And what would y do? If I did have to switch these limits. Are you guys kind of with me? X would go from 0 to this ugly number. Yes, poor little number. Didn't even ask to exist. So X goes from there to there free. You can just do, you just any value, bless you, that X happens to be at that moment. So just pick an X randomly in here. What is Y doing at that X? It starts at, good, 1/7 X, and it goes to, yes, Y equal that. You guys kind of with me? If I'm trying to figure out what Y is doing, and I've got these walls it goes between, each wall has to be Y equals something. Y is this here, Y is this here. Is that better? Is that okay? All right. So trust me, this is why I tried to say, and again, it didn't really make a lot of sense if your teacher didn't show you a lot of, like when I did cylindrical shells. Do you guys remember cylindrical shells? I try to get my students to draw a representative rectangle because then they can figure out the height really easy. You have something you can actually look at, yes? So if I wanted to rotate this region around the x-axis, a representative rectangle would be like this. It would be at a y position, so my radius would be y. So that's why I was trying to say it's what you have to do is related to what you should have done then. Because it's really hard to tell what goes where unless you are giving yourself a visual. Now, on a lot of problems you're going to have to do in 15, not a lot, on a few problems in 15.6, you probably want to try to graph in Desmos 3D. Dear God. But you really want to work directly with traces in each plane. So we'll do an example, at least one example today with how that kind of works. But before I go there, any other specific questions from the quiz? Or general questions from the quiz? Or questions from homework stuff? You guys doing okay? No? It's kind of funny. There are, I was about to say it's that time of the semester, but there's a lot of times in the semester. Yes? Basically, any time in the semester you can go, it's that time. Just to let you know, your teachers feel it too. Trust me. But you're all like, you're the man making me do this shit. No, I'm not. You signed up for it. What do you want? You didn't have to be here. Anything else from the quiz? What was the other problem? Oh yeah, we talked about both problems basically. Yeah. Okay. So, as always, work on corrections. If you didn't know this for some reason, you can get help with your corrections. You can go see tutors. You could give the corrections to me and say, I'm not turning this in. Can you let me know if they look good? And I'll let you know if any don't look good. And if I have time in that moment, I can help you with them. It's crazy. Huh? Okay. So who do you go to for help with anything related to your math class? You go to me. You feel like, dear God, I listened to this guy enough already. You could go see tutors. Yes. You could even go see, I've got people that come by to see me that aren't in my class, and I've got my students that go see other people. They're like, I like this guy better than you. Let me go see if he'll help me out. And sometimes we'll help out if we don't have our own students in the classroom. Yes? In the office. Yes? But my point is, anything you're working on, homework, corrections, whatever, you can get help with them. Yes? And I am one of the points of contact for help. So if you extend that idea, that means if you just say, hey man, do these look good? I will tell you which ones don't. All right. Is that okay? So the people that don't get any points back for the corrections, it's just wasted time. I want you to get something back for that work. Okay. All right. Anything else? Anything from quiz, homework? Is homework going okay? What's up with homework?
Where is it?
Huh? I want somebody to go, we have homework for this guy. Are you sure about that? So just to let you know, I am, we're going to do some examples from 15.6. I've got the practice test with me, of course. The test is a week from today. Did I already tell you guys you're going to have a sub for the test day? All right, because I'll be conducting interviews of English faculty, which just seems so right. Me grammar good, so me should pick English teacher. So anyway, so I'll be kind of busy all day. What is it? 8 to 5. We're going to be doing interviews. Okay. All right. If nobody has questions, is that true? We're going to do some examples from at least 15.6, unless somebody has some questions. So if anybody has a specific problem you want to kind of explore, let me know. What is it?
I mean, my questions are kind of from 15.6.
Let's do it.
Yeah.
What you got?
No.
Oh, you mean you have general questions and you're like, dear God, please address some of them. Huh? If you have one that you want to look at, let me know. Otherwise, okay. So the whole idea of 15.6 and the way that I try to make the problems a little bit easier to approach, because in 15.6, we are extending this double integral idea very directly. We just add another integral, oo, but that means we're actually integrating across a volume. So that means, one example I gave you was the temperature at each point in the room, right? Not the temperature, but like the heat flow. So if I integrate across a volume, I can see the total amount of heat flowing through that volume. So a lot of physics is measured in flow rates, and then if you integrate, you can see the actual amount, total amount over whatever time. Okay. What gets trippy is all of a sudden, it was hard enough when I had a single plane with a region, and then I had to like scan the region, yes? So like what we just did a minute ago with the triangle. Now I've got to scan this three-dimensional region, which obviously is worse. So an immediate thing I can do, just in general, is for any given problem, and I think I have a specific example with this. Yes, here we go. Let's look at this thing. I don't know where this came from, but here it is. And this is contained in here. Can I read my own writing? Yes, okay. Let's see where I got this from. I feel like I'm forgetting something. There it is. Yeah, okay. It's so y equals x squared plus z squared. So in the xy plane, what does it look like? The trait for y equals x squared plus z squared. In the xy plane, what does it look like? Like a parabola. In the yz plane, what's it look like? Parabola, right? So it's kind of wrapping around the x-axis. So in the yz plane, here's the x-axis, it's a parabola. In the xy plane, it's a parabola, so it is a paraboloid. Yes? Just going forever. It's this parabolic bowl, basically, that just goes up. You can think about it like one of those giant planters for those long ass, those trees. You know what I'm talking about? It's okay if you don't. Okay. That's right. So I mean, you could, even that boundary is itself three-dimensional. So you could just plot that, and you can see it's a paraboloid. Right now, do I give a shit about the square root of x squared plus z squared? No, I don't care about that at all. Let me see what you guys think. For this problem, there's kind of a natural. I try to figure out which plane does my big D live in? Yes. So in section 15.4, I think it's where the double angle started. Is it 3? No. I think it's 15.3. I had to consider my region in my XY plane. That's basically what it almost always was. Yes? So here, I'm trying to figure out which plane holds that. So I want to rewrite my volume as D letter dA. And the dA is going to be kind of like related to that region when we were just doing double intervals. So we don't have to consider everything at once, thank the gods. Can anyone see what plane my region D should live in? A plane is more than a single letter, yes? So I got somebody saying XZ plane. Do you see how y, what does y go between? X plus z squared and 4, yes? So in this case, y is acting like z would normally. And doesn't y equal x squared plus z squared have very simple traces in the xz plane? Yes. You guys with me? So, I can't say anywhere near it will always be as simple as this to figure this out. But if you break the problem down into what do I want to look at as my main plane? Yes? So in this case, I want to consider the XZ plane as my main plane. And I'm going to figure out everything for that for dA. Which means, which letter did we leave out? Yeah, so I'm going to consider region D, which is what we did when we had just two integrals for a double integral, is going to be in my XZ plane. So dA is going to reference to that, and therefore this will be dy. So let me stop for a minute. One of the hardest things is, well, let's say two things. One difficult thing about triple integrals is, holy shit, we're just getting used to double. You all agree? You're like, yeah, dude, just didn't think you'd say that. Secondly, the hardest thing is now there's like a whole other dimension, and your brain is like, how am I supposed? I can't even hold two in there at once. Now you want me? So it's not about holding all three dimensions in your head at once. Your first step is, what is the main plane? And here's a picture of what I'm talking about. I'm not gonna. So here's an example of what I'm talking about. Right here, for example, or either one of these. So they are given a region E, and they have determined that their YZ plane is where this is. And then X goes from this to this. So what we just did is we determined that this region D lives in the XZ plane, because it made sense with what we were given. So this is in the XZ plane. And then dy is just going to sit on the inside. How are we doing so far? A little bit? No? So I in every math class you take, you have all this concept. Holy shit. Teachers love the concept. And I've been told, dear God, Jeff, give me something concrete. I'm like, I'm sorry. So I try to figure out, within the concept, when you have an actual problem in front of you, what's your plan of attack? And to make triple integrals easier to kind of like break down, this is your plan of attack. which plane does it seem the third variable sort of depends on? This one is definitely in your face. Y goes between two very distinct things. X squared plus Z squared equals Y has very easy traces in the XZ plane. So the XZ plane, this problem is just screaming at you. Your little green D area should be in the XZ plane. Okay, so what the shit does that mean, Jeff? I don't know. Oh yeah. So can somebody tell me, we already know this. What does my Y go between? Because now I've identified dy is the interior integral, yes? Sorry? What? Let's do it again. What is my Y going between? Yes. So, if you graph this thing, or even if you just consider the fact, so I'm going to have my x-axis going like this just for now, just because it's easier. This is my bowl here, right? It's parabolic all the way around, yes? So I could do like a little ballerina moment, but it's going to go from the edges of the cylinder to its top. With me? So I'm scanning the region. Okay, I like it. So it's going to go from x squared plus z squared up to 4. So this is kind of, I need you to see how this is kind of nice. Now, with everything in mathematics, when you have to make a choice, could you make the wrong choice? Yes. But at least you have a plan of attack. If your next step makes no sense, maybe your first choice was wrong. Does that make sense? Mm-hmm. But at least you have a methodology, a recipe to follow. So now I can focus all of my attention on the next choices I have to make. What's the next big choice I have to make? Yeah, is it going to be dx dz or dy, I'm sorry, dz dx? Yes? For my dA element. A dy has been set, and that feels good. I got 1/3 of my options set. Yes?
How did you know it's x squared plus z squared is at 1 versus
Okay. So if you attempt, here, a really good idea on most of these, and I really should have started with this, and I sort of did with what we were talking about. If I try to graph some, here, let's start off with the XZ plane. If I try to graph some traces in the planes, yes? These will be circles in the XZ plane. Yes? For any value of y. In fact, a really important one is what's the biggest y can be? 4. So that would be a circle of radius 2. But then other traces would just be other circles with smaller radii, correct? Now, let me see if you guys, again, on a test, I will give you, where I deem it will be helpful, I will give you like a 3-dimensional graph, yes? On the homework, you can certainly graph this. And again, it's this cylinder. So like, what does it look like in the YZ plane? Parabolas, yes? Okay, so I'm just going to draw one just to be representative. So in the YZ plane itself, it is y equals z squared, yes? Sorry. And be really careful, what does y equals z squared look like? Yes. And in the xy plane, of course, what's it look like? Parabola. Right? Y equals x squared. Okay. Now, how do I say this? Do you see if I put the y plane kind of like in the same orientation, if I actually drew this with the y plane sticking this way, it would actually be this also? So it's doing, here's the x-axis, it's doing this kind of thing as it moves. And it gets larger as it goes because the cross-sectional circles get larger radii as we move up. Yes? Okay, so let's see what Jeff can do. If you try to graph this, I'm going to make this my x-axis. Okay, this won't be too terrible. That's not too, okay. If I try to scan this region,
I'm sorry, y-axis, yeah. What does y go from to, given any points in my region here? Given any points, where does my y go from to? This wall to that wall. So it goes from the edge, and what's the edge? X squared plus z squared. Up to the top, which is 4. Yeah. And this is why it's a really good idea. Now you have to let me know if you have absolutely no way to access a computer. Because for several, not every one, but for several of these, it's really good to graph what you're trying to work with. You know, I could do a whole back in my day moment. I talk about my teachers and they drew worse than I did, but we didn't have anything that would draw anything for us, so that's what we had to work with. Yes?
What about the exam?
Like I just said. What did I just say? Was anybody here?
The computer?
Did everybody walk away?
If we need it, you'll give it to us.
Yes, if I deem it necessary, I will actually, on a few problems, I'll give you the 3D image. You with me? Okay. So if I don't give it to you, I'm saying you don't need it. You should be able to figure out what you need to figure out without it. Okay. Let me stop for a minute. How are you guys doing? There's no way to like simplify this as much as you want me to. There just isn't. Because there are considerations to make. But where can I get it to? This is my first step, is break the DV down into at least 1 dimension, 2 dimension. What is this one based on? The plane that I think my region should kind of live in. Yes? Okay, let me see. So does anyone have a preference in terms of, because what's my next choice I got to make? Like we said a minute ago, is this dx dy or dy dx? Yes? Do you see anything in the problem that actually says it should, I'm sorry, yeah, dz dx or dx dz? Is there anything in the problem that tells me it should be one way or the other? Everything related to x and z seems to be symmetric.
Yeah.
So I have it. So, what's the first thing I hear? Say something. What, dx dz?
Yeah.
Oh man, that's crazy. All right, we'll do it. So we already got the inner one figured out. And I know there's symmetry here, but I mean, that's just because that's the function they gave us, yes? So, all right, let me see. This is a region, sort of like the room could be a region. Don't you agree this room has equations for its boundaries?
Yes.
Every boundary, yes? In this room, I could have multiple functions representing the old favors, heat flow, charge, whatever, yes? Whatever I could possibly, you just had it, humidity, whatever I could measure, yes? That would be the internal function. The limits are talking about what region am I analyzing that over. You guys see that? This problem is a little bit tricky because part of the inside looks like what's in the limit, but that just is a coincidence.
I mean, that's the same thing we did in 2D, in like Math 180. You look at it, it's like, well, what the actual limit says, that's a square in the xy plane, but we're talking what's inside is that function, and we do what's that function.
Okay. Yeah.
The regions technically is kind of like a square, if we just look at what the values are. Kind of.
Oh, for this one?
No.
No. All right. I was gonna say that would be neat.
Generally, kind of makes the weird kind of rectangle.
Yes. Okay. Okay.
Like weird angles.
Now I've got to figure out these limits, and let me ask you this. Let's just try to do this. We basically just figured out what the shadow of this is in the XZ plane, because the biggest Y can be is 4, yes? Let me see if you guys are really cool with this. Here's this. Here's D. Yes, and it lives in the XZ plane, so I just took my coordinate system and rotated it just so the Y-axis gets to be up and down. Do you all agree that it gets a larger radius as it goes up? Therefore, the region in the XZ plane from which the points, the inputs create the outputs on the surface
line the same circle as the one up at 4 does. Yes? This point would go to here. A point on the edge of the circle would go where? Yes. Right? This point goes to itself. Yes? A point over here goes up a little bit. A point on the other side goes up that side. Yes? So that contains all of the inputs that actually have outputs on the surface. Okay. So there were some problems in 15.3, I think it was, where they gave us the region. There are some problems here where I actually have to determine what the region is going to be, which makes sense because the first choice we had to make was where the shit does that region D live? So if I chose a different plane for that to live on, it would be differently shaped.
Maybe. So, let's do this straight up the way this is. What's the equation of this circle? Four. I like it. Yes? You chose dx dz, yes? So which one is able to do everything it needs to do without any care? Z. It's on the outside. The outer integral will almost always be, for every problem we do, it will always be. We'll just say that. The outer integral will always be constants. Yes? Because by result should be a number. So the last integration I'm doing should plug numbers into the last variable that's living. Yes? So there's no variables at the end. I just get a number. So what can I put on the outer? The outer limits.
0 to 2.
No. Negative 2 to 2, right? So z is going from negative 2 to 2, yes? Now, here's where things get trippy. What is, for any value of z, what is x doing? Now, real quick. Do you guys see that's the thing I was telling you you need to do? The little dumbbell you draw in. Goes from this one to this one. I need a formula for both sides of this. Solved for what? X, because this is supposed to be, I'm asking what is x doing? X goes from x equals this to x equals that. So what are the formulas for either side of that circle? I just solved this for. I solved this for x. Because I need to know what x is doing. Yes? I already know what z is doing. So x will be plus or minus square root of z. Thank you. Okay. So obviously, the negative part would be this part back here, because that's where x is negative, yes? So x goes from this wall to that wall, so what goes here? Negative square root of 4 minus z squared. Positive square root of 4 minus z squared, yes? Now, real quick.
Once you get past the first decision and the second decision, first decision is, what's my main plane? Where's the plane that has the inputs that generates the shape? Yes? And in some problems, it doesn't matter which plane you consider to be the main plane. Sometimes there's kind of something that makes more sense naturally. That's this one. Once you get those two set, then it's just, at this point, old news. One variable is just going to do what it wants to, and then the other variable I have to be very distinct about. So if you're going to draw anything, you have to at least draw a picture of your region D, because then you can kind of analyze it to get your limits. Is anyone terribly excited about eventually doing these? No. Let's do the first one. The inner integral, yes? Why is the inner integral really easy? Now, I want to adjust something I said earlier. Do you see why that dy being on the inside makes even more sense now? Because if that was dx or dz on the inside, I don't want to do trig sub on that. Do you want to do that?
No.
Do you see what I'm saying? So, this is what I meant by you could choose the wrong path. It should be relatively quick you notice, oh shit, I chose the wrong way. Let me go back and pick a different way. You guys with me? So can I give you like 7 of these problems in the test? Let me ask that a different way, because I could. Would that make logical sense? No, because you could be unlucky and choose like the wrong way several times. And then, you're like, I got 6 more of these things. So I'm not going to give you a ton of problems that involves all of these decisions, because you could just sort of like randomly make the wrong decision. And then you're screwed because you're taking up so much time. Are you guys kind of with me? You're going to at least get one of these. Okay. So, I'm sorry. I cut somebody off. How do I integrate the inside? Y times this. And do you guys see, if this is not dependent on this variable, if I put a y here and then I plug these in, I'm just going to get this. Yes, no, maybe so?
Yeah.
Y a value of 4, that y a value of that, subtract the 2, well, there you go. So that first level of integration, that inner interval, was not hard at all because the thing inside didn't care about y. So I got to just plug a y in. So there are a few of you guys that have little notes to me saying, I don't have an x inside. Well, once you integrate, you have to have an x inside. What's the only way you can integrate something dy and not end up with the y inside? Yeah, what'd you say? 0. Yeah. If you integrate anything else, you're going to have some function of y inside, yes? Integral of 2 is 2y. Integral of dy is y, yes? Okay. So there's always going to be somewhere for those limits to go. Let me stop for a minute. Some of you guys look forlorn, and I'm sorry. Okay. All right. Having a bad day because I made a student cry this morning. So I'm kind of a little extra noticing things. Okay. This is not easy. This is calculus flipping 3. So, it's not easy, but I want to give you things to try. If you show me you know what to try, even if you don't get to the end, I will give you points. Because you've shown me you understand what you're trying to do. If you give me some pictures, you give me some thought process, you show me what you're trying to set up, if you're going the right way and you just ran out of time or whatever, I'm going to give you more points than a bunch of stuff that's been erased. Does that make sense? You guys with me?
Yeah.
So if there's a problem you're having a lot of trouble with on a test and you do some stuff, don't just erase all of it necessarily unless you really know you made a mistake and you know exactly what to do. Right? If you're like, I have no idea, leave what you have done. Because maybe there's just one little mistake you made that made the rest of it impossible. And I'm like, oh shit, that sucks. You would have been great. And I will take off a few points, depending on how much is left undone. But you will get points. You with me? Okay. All right. Does anyone want to do this? All right, we're going to do it, but we're going to be smart about it. Does anyone see something? I totally want to go to polar. Yes?
Yeah.
What plane are we living in now with this integral that I have in front of me? XE plane. So now I can do polar coordinates in the XE plane. Doesn't have to be an XY plane. Be whatever plane I freaking want it. And in fact, after this test, we're going to take polar to 3 dimensions. Why not? We're going to do it. Yeah, we're going to do it. So you can't talk yet. So let's see. Coming back to this. What's a better way to identify, like, what is the definition of the circle in polar coordinates?
What is the most important aspect of the circle in polar? Because what is polar coordinates again? R theta.
Yeah.
So can somebody tell me what angles encompasses that circle? From what to what? 0 to 2 pi makes the whole circle, yes? What else do I have to tell somebody? So I tell them to rotate 0 to 2 pi. Oh shit, I should have first told them to go out
0 to 2.
2 steps and then go 0 to, and then you would get the freaking circle, yeah?
Yeah.
So a definition of the circle is r equals 2. And to create that, r equals 2 is just a point. To create, I go through all the angles and then I create a circle. Yes? Now, to be honest, r equals 2 is the whole circle because theta is not bounded. Or we're going to bound theta. Why are we going to bound theta between 0 and 2 pi? Because otherwise you just start to retrace the damn. Okay. So I'm going to change this shit here. What goes here now? RD theta. On one level, it takes less to do this than you would think. We're doing it right now. It doesn't take a lot to go from, now the worst part about going from, what do you call it? Not even that. No, I'm not even going to say it. This has nothing wrong. RD theta, that's just what dA is in polar. Yes? Why is the R there? Because it has to be. Otherwise, that ain't dA and the whole thing goes to shit. What do I need there? D frickin' A. Okay. What is this then? Well, actually, let's start here. What's this? Square root of R squared is R. And what is this? 4 minus R squared. Yes? Because x squared plus z squared is R squared in my xc plane. Yes? And the great thing is, don't look at this shit. Don't look at this shit. Just look at this. What is R going from to? 0 to 2, as theta is going from 0 to 2 pi. I don't know if any of you are going to get from this what I want you to, but the more coordinate systems you know, the more integrals you could do. If I didn't know polar existed, could I do this? Maybe. But dear God, this is so easy. Look, this is polynomial in R. Give me a break. Right? Do you guys see that? There are other problems, especially when you go to 3D, that they don't work in XYZ. They don't work in this other one. They don't work in this. If I just knew this one, it would work beautifully. So the more coordinate systems you're aware of, the more integration you can do. Because, I mean, dear God, that problem became from stupid difficult, maybe impossible, to stupid easy. Yes?
Does the inside formula takes care of all of the shape? Because it's not just round, as you showed us.
Are we in 3D still? The integral I'm looking at, are we in 3D still? Is that what you're worried about? I don't have to worry about the entire three-dimensional object because I've already done one integration. I'm in 2D now.
I'm worried about, by the picture, it looks like it wasn't the circle, like perfect circle, it was like, you know, at the dents and all the stuff like that.
What picture? Sorry.
The one you, the
Oh! That I showed you from the book? That was
on the website.
the website. This one is a perfect circle because this is a perfect circle. Yes? Every point in the circle goes to a point on the surface, and the points on the outside go to a point at the rim. Yes?
Maybe
Does it make sense?
Yeah, maybe I'm thinking about it.
Okay. Do you guys see how that problem is still easy now? So I would get, I don't know, I gotta be careful when I say that because I don't blame you if you're like, what the hell, this should be 4r squared, this should be r to the 4th. You guys see that? R squared outside? And then you distribute that.
Oh, I see.
Nice. So the inner integral
Becomes
4/3 r cubed minus 1/5 r to the 5th. D theta, and this is evaluated between 0 and 2. Right, so now I'm kind of losing interest. Good for you, Jeff. So this will be, the 0 will make it 0, so just don't worry about the 2. So I'll get 32 thirds minus 30, oh, that's neat. Did I do that right? Yeah. Minus 32 fifths. Haha. Yeah, it'll be 64 fifteenths, yeah. And then when I integrate that 0 to 2 pi, what do I get? Oh man, the king of enough room here. Okay. Integral 0 to 2 pi, this would be 64 fifteenths. 64 fifteenths theta.
And it's 128 pi.
Is that okay? Sort of? No? Real quick. Guys, how tall was this again? I haven't done what I'm about to do, but I'm curious. It was 4 tall. This is not a cone, yes? If I pretended like it was a cone, it seems like that volume would be a little less. Do you see that? Because the side should bow out. You guys with me? Do you guys, well, now the next question is, do you know the formula for the volume of a cone? Do it again? No? A cone is cut out of a cylinder. A cylinder would be pi r squared times h, because you have a circle repeated h times. So a cone would be 1/3 pi r squared h. So, I don't know if you guys are even paying attention anymore, but the radius of the circle up top was 2, remember? So 1/3 pi r squared h would be 1/3 pi times 4 times 4. So the 1/3 pi times 16 pi over 3. How does that relate to this? I don't know. If I divide that by 5, right, I'll get 3 on the bottom. Jeff, it'll be 25.6. Is that right? If I divide this by 5? Anyway, it doesn't matter. I'm sorry. Everything I just did was sort of extraneous. Very often, if I have a shape, I'm trying to figure out, oh yeah, we're not really doing the volume of that thing, are we? We were integrating this, oh yeah, so that's why it's way off. We're integrating a function across that. I'm sorry. If I was doing a volume of something, and I can sort of approximate it with the shape I know the formula for, I can kind of check to make sure it's close to that. I forgot we weren't getting the volume, we were actually doing this function. Yes?
So the question, what are we doing?
You mean everything I just was talking about?
No, because I understand double integral, we're doing the volume. Because we have
No, careful. No. If the inside of a double integral is 1,
Yes.
then we're getting like an area.
But
If the inside of a double integral is 1, that is like a flat plane 1 unit from the region. That is a volume, but it ends up being equal to the area. Is that cool?
Yeah.
If I have a 1 inside of a triple integral, I end up getting the volume. You with me? Okay. So I'm sorry, I forgot. We weren't getting a volume. We were actually analyzing the total value of the sum of that function across that region. That's square root of x squared plus z squared, which is very much not 1. Okay. All right. Do you guys want to do another example? You want to take a break? What time is it? You guys want to take a break? It's up to you. Yes, let's take a break. Come back in like a little after 1:40. Getting back into this stuff. If nobody has any specific questions from 15.6, I'm just gonna pick another one to kind of go over with you guys. Yes. Let me see. Here's all right. We didn't do this one last time, did we? This one here. No? Yes? No? Does that look familiar? No? Okay.
Is it okay if I take a picture of the bottom part of the notes that you were just giving us?
The bottom part of.
Yes. The two integrals, it was 2 over 2 pi, or 2 pi over 2 over 0.
Oh.
my bad. Yeah, that one.
Go for it. Oh, and then this was the result.
I want to take a picture if I want to. I couldn't finish it. Thank you.
Thank you. So we wouldn't have to divide it by anything, right?
Say again?
For the final result, it's just the 128 pi over.
Yeah. Yep. Okay. And then I did some weird stuff, and I'm sorry. Let's do this one. You guys, hey. Try to set up number 17. Do you notice? All right. 17 is very direct in terms of helping you with what your first choice is. And what is your first choice in these kind of problems? What do you have to choose?
What's the first one that's not the...
What's the main plane? Right? What's the plane in which the inputs live that make this? Can anyone see how they kind of vary very directly?
It says X, Y.
Isn't that crazy? Alright. So try to set this one up. This one's a little easier than the one we just did. So that's why I'm going to let you try it out on your own. Obviously, you're going to work with other people near you if you want to. I'll catch up to you here in a minute. By the way, somebody asked me earlier, is this the place where students really kind of lose it again? Understandably. Very understandably. Yes? I need to stress to you guys, these are not simple, and yet for some reason, I'm still going to grade you on how well you do them. But focus on the approach to take. I'm going to give you at least one problem like this, where it is remarkably clear what your plane is, where dA lives, yes? And I'm going to give you at least one problem where it isn't. And you have to kind of figure out, like the one we did together just a minute ago, yeah? Or 10 minutes. So what are you guys all doing right now? That's what I'm curious about. So everybody got what they need from this? So everybody got written down what you need from this? So I can move this aside? Thank you. Since this problem tells you your first choice directly, how can I rewrite this? Oh, I'm sorry. You guys are so needy to be able to see what I'm writing. This piece. How do we write this piece? I'll put dA right there. DZ. All right, I like it. So that's the first level choice you can make. And now you can focus all of your attention on dA. Does anyone know what goes here for Z though?
2. It would be 2 or 2.
Oh gosh, I can barely see you. Where's that? 17. Okay.
2 plus I squared.
Yeah. What's it live between? Z equals 1 plus X plus Y, right?
And then Y
and above the region in the xy plane. So the absolute lowest z can go is, what's the definition of the xy plane? Z equals 0. So z goes from 0 up to this, yes? Once you identify which plane holds dA, then you can kind of focus on the letter you left out. In this case, z, and we can go, okay, what's z go from to? It goes from that plane up to this value, yes? So it goes from that plane up to this value. Is that always going to be 0? No. But it has to tell you kind of like a way to get the bottom and a way to get the top. In this case, it went from the xy plane, z equals 0, up to this 1 plus x plus y canopy above that. Yes? Okay. What's your next level choice now? Yeah, so what should I be graphing for myself? Region in the xy plane. So I know it's y equals square root of x. Where'd you go? Y equals 0. What is y equals 0? The definition of? X-axis. I love it. Some of us get that backwards. Again, there's a lot of shit going on. I understand that. But just make sure if you get the wall in the wrong place for your region, everything else is going to go to shit. Thankfully, I have a teacher that doesn't use the Scantron, so I actually give you credit for... You'll lose points for that, but if you did everything else right after that, that's the only points you'll lose. Yes? All right. I'll give you a minute to finish up if you haven't graphed that region in the xy plane yet. Everybody else not get their quiz back yet? Is that everybody? Oh, I'm sorry. I need to remember. No, you should get it back for now, just so you can help. You can. Oh, that was it. I was thinking about it. So but is this fx or fy? You see, it's got to be exactly. So I need these to be. This is not even okay. So I need you to see how in a different problem you can end up with what you think are put up one set of ones. Yeah. But I will give you back a point and then just make corrections. The easiest way to do this problem is to when you set this equal to 0 and you get y equals x squared. Set this equal to 0, you get x equals y squared. Plug 1 into the other. Right, that idea of substitution with systems of equations. Yeah, so right here, y equals x squared. Here, x equals y squared. X equals y squared to replace y. I'm sorry, replace x with y squared. Then you have an equation with just y. You get exactly what y is. And then you plug it back in to see what x is.
Where does the x goes from?
Oh, all right, here we go. Sorry, guys. So I'm going to graph this. X equals 1 is a wall, yes? Y equals 0 is a wall. X equals 1 is a wall. I got my choir over there. And then y equals square root of x is a wall. Where does that hit this wall?
1.
No way. Okay. So it's very determined, yes? So now it's up to you. Which way you do it, completely up to you. Because it's pretty easy to turn the sucker around, yes? Because that's easy to rewrite in terms of y, right? Solve for x. Do you need to? No. Do you want to?
It doesn't matter that much.
Okay, let's not. So then if I leave it like this, I've got my picture now, which is much easier to look at than this. So from my picture, so tell me, what did we just decide? What do I want dA to be? dy dx?
Wait, why is there an extra D after the x? Is that supposed to be y?
Oh yeah, it's supposed to be y. Thank you. Thank you, Zach. That's called Jeff is freaking tired. Okay. We got this one figured out. Which variable now, since I've made all my choices in terms of the ordering of the integration, which variable can do what it wants to? It's free to go amongst all of its values. X. So what is X doing? 0 to 1. Bless you. Now pick everybody, every single person in here. Just pick a random value that X can be. Preferably not 0, because then you don't have anywhere to go. Sure, I'm just going to put it here. Because I want to be contrary. Right? So where does y, for that value of x, where does y go? From 0 to, yeah, what is this? This is y equals square root of x. So from y equals 0 to y equals square root of x. That's what y does. Thank you, Rory. It's nice to have validation. All right, are you starting to see what you need to consider to try to construct this? Maybe? No? I'm not asking, are you able to do every single problem I give you? I'm asking, if I give you a problem, do you know what considerations have to be thought about, right? So now we got everything set up, we can just attack this silly thing. What am I taking the derivative with respect to first? Z.
Isn't it the interval?
Integral, thank you. Is that you again, Zach? I need somebody. I just need somebody. A live fact checker. So what is the integral of 6xy dz?
6x.
That's crazy. And evaluated from 0 to 1 plus x plus y. So when you plug that stuff in, I'm going to get 1 plus x plus y. I'm going to shove it here, yes? And then I'm going to distribute the 6xy. Is that cool? So it'll be 6xy times 1, 6xy times x, 6xy times y. You guys, is everybody cool with that? It's really nice when you integrate and the letter you're integrating with respect to is not there. You could basically just shove the limits in subtracted, and that's pretty straightforward. That's exactly what's going to happen. This integral is relatively simple now, right? Especially with the 6's there. 6 is an awesome number. So I'm integrating with respect to y. So what's the integral of this? 3xy squared. I love it because x is a constant.
Plus 3x squared plus squared 2 plus 2
Good.
x y.
And evaluating that between 0 and square root of x. Just to remind you guys, you chose to do it this way. One reason you might have wanted to switch is because you know eventually you got to plug that in. And if you get lucky, maybe every power is even.
It's not.
It's not. But it's okay. It's not that horrible at all. Does everybody understand what I just said? Does it really, really change things? No, but I mean, there are little considerations to take when you do this. But let's see. When I plug this in, 0 will eventually not do anything, so I could just sort of forget about him. Be very careful of have e to the x in there, and you have a 0 that will make 1, yes. I mean, that's like happened in Math 180. So don't just totally ignore the zeros. Or, yeah, like cosines in there or something. Yeah, exactly. So I'm going to throw a square root of x in here. I just get, well, 3x squared, good, plus square root of x in here. Again, that becomes x, so it's 3x cubed. And of course, we get this poor little dude. Yeah, this will be x to the 1/2 to the 3rd is x to the 3/2, and then Zach said just put those things together, Jeff. Add the powers, you get 5/2. I like it. You would, Jeff. And now when I integrate dx, what do I get here? This is nice. Yay! What do I get here? Not as nice. And then I should rewrite this. It'll be, what I always do is I have x to the, what's the new power? 7/2. So I'll have 2 7s times 2 out front. Let's see if we get the same answer I got, because I did it a different way. Yeah, 65/28.
I pulled 6 out initially, so it's slightly messy the entire way.
Oh no!
It's just when you're doing fractions instead of it being nice numbers, but there's numbers.
Yeah, when you're doing polynomials and you see numbers that have 2 and 3 and 4 and stuff, you leave them because they're gonna provide me with the powers I need. All right, half of that problem should have been easy. You know I'm gonna give you at least one problem where the interval's already set up and you just have to evaluate it, correct? So let that part be nice. It's when you have to set the interval up. That should be the part that's tricky. Okay. So I did it. Did I do it a totally different way? How did I do it? No, I did dy dx. So what did I do? Oh, I see what I did. Okay. I did the different order in the xy plane, but I still got 65/28. So no matter which way you do these, you should get the same answer. All right. So let me do this. Because we could just do another problem out of the homework. I'm gonna give you the practice test. Let's see. Oh yeah, I'll put the back on there again. Somebody asked a good question. Am I going to put the interpretation for the second derivative test? Yes, I'll do that. I think you guys have enough to worry about. So that same little thing I put on the quiz, I'll put that same little box on the test. Yes, interpretation of these stuff. Okay, so if there is a problem on the practice test, especially one related to what we're doing right now, we can take a look if you have anything from homework. We can take a look.
I could just pick another problem out that we could do together. Yes?
Just a question. Will so I did last class the surface defining surface area. Will that be on the?
Yeah, totally.
I don't see it in the practice.
Oh shit!
I read a few other questions. Another one specifically for surface area.
Did I forget to throw a surface area problem? I probably did. Oh yeah, I totally forgot to put one on there. Yeah, so that will be on there. Yeah, I just forgot to put it on there. I Frankenstein this together from old practice tests. And each semester the pacing is different. So I must have just grabbed some from one that didn't have that on there. Shoot. Yeah, so 15.5, the surface area stuff, will definitely be on the test. I'll have one problem from there. Do you guys have a way, do you guys remember the formula for surface area?
It's the integral.
Yes?
It's the integral.
What kind of integral?
Double integral.
Double integral?
The square root of fx squared plus squared plus 1 dx.
Kick ass. Like so many guys are like, are you going to lecture about that right now, Jeff? I did. Now, I told you, the funny thing with this problem, and again, if on the day of the test you forgot, maybe I'll put this on there because it's not that big of a deal. And I told you, I assigned very few problems, if I remember correctly, because in terms of all the methods we know to integrate, it is very contrived kind of problems that this ends up being something we can do. You guys see what I mean? Anytime you have a big ass square root over a bunch of shit in your integral, it's almost, if I just randomly pick some stuff, you're not going to be able to do it. It's going to be impossible. So I have to pick very kind of contrived problems. So if I assign more homework, you're basically doing the same problem over and over and over. Because there's only certain kind of problems that actually kind of end up becoming integrable by hand. Yes? Are you guys kind of with me? I like this problem because it marries the idea of partial derivatives with integrals. It's like line integrals. I don't know if you guys did that in math. Where would you have done that? Not line integrals, but integrating, getting arc length of a curve.
Oh, that was Calc 2.
That was Calc 2? Yes, okay. I'm teaching Calc 2. Oh yeah, that was at the end when we did parametrization. Yes?
Something like that, yeah.
Did we do it in here? Yeah, we did. Okay. Yeah, I'm teaching so many classes that overlap. I forget which thing is where. Okay. Yeah, real quick, just because I want to. If you look at, I don't think it's that though. I think it's back in 8. Okay. Sorry, this will just take a moment. I have to go off on my tangent. Here we go. Arc length. There's the arc length of a, just in XY plane. That's the equation for the arc length.
That's really similar.
I know. In fact, don't we just basically add one more term in? Instead of dx dy, be dx dz plus dy dz. I'm sorry, other way around. dz dx dz dy. It's kind of like the Pythagorean theorem, extending whatever dimension you're in. Yes? Same idea. You just can add more and more elements to it. Okay. Sorry. So that would have been Calc 1. A lot of time we run out of time and we don't get to Chapter 8, which is unfortunate. But this is going to come in big time in Chapter 16. So I wanted to make sure to at least give you a few problems with this. All that said, is there anything specific you want to focus on? Do you want me to pick another triple integral problem to kind of go over with you? Is there triple integral problem on the practice test you want to look at? Blah, 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 blah. I like number 10, yes.
I want to look at 3. That's
Three?
like a, that's not like a.
Oh yeah, 3 is a great. All right. A lot of time, I will ask a question on a practice test just to make sure I have time to talk about it on the data review. I kind of mentioned something about symmetry very quickly at one point, and I think I almost basically just said, don't try to use it. Because it has to be very specific. Do you all agree that in 2 dimensions, R is twice the area of X? Yeah?
Twice the man you are.
So, but does that mean I could have this double interval of f of xy and just say across R is twice across S? Why can I not generally do that?
Because we don't know what the region of
The function could be lowered here.
If the f of xy was just a flat plane, I could do that shape. Because this itself is symmetric
Yeah.
across that region.
It's like-
The minute it has a tilt, I'm screwed. If it has some wavy bullshit, I'm like crazy screwed.
If it's sinusoidal, it can be nice.
Huh?
If it's sinusoidal, it can be
True, but I purposely made it have a bit of a
Yeah.
higher amplitude. If the function itself is not symmetric over this region, I can't do that. I don't know if you guys remember doing this in Math 180, maybe in Math 280, where you had something from like negative pi over 2 to pi over 2, and you can make it 0 to pi over 2 and double it because of the symmetry. I don't know if that sounds at all familiar to anybody. But when you have this third consideration, you can't do that generally. Okay.
Yeah, because to make the analog, if we're thinking about it, literally it's just, we can have like a problem that's from 2 to 2, from negative 2 to 2. The region that is symmetric, but the function above it, it could be a y equals x. That's not
So if I was
symmetric.
doing the area under y equals x squared,
Yeah.
negative 2 to 2, I could do 0 to 2 and double 1 again. And of course, you can see the advantage is one of my limits is 0. So a polynomial, I'm going to be able to forget about that.
Yeah.
Right?
And when it's y equals x cubed, it doesn't work that way because the function you are working with is not symmetric.
Well, with odd functions, it's nice because
It's just
then it comes out to be 0. Is that okay? You guys see the point I'm trying to make with number 2? And I have no idea if anybody's tried to do that because I haven't gotten a lot of homework yet. But don't. Unless you're absolutely certain that this is symmetric up here. Yes? So if what you had above this region was part of a dome, of a sphere centered at 0, 0, 0, then you could totally do it. It would be symmetric.
just because the region is symmetric does not mean the function is symmetric.
Exactly. Anything else from this guy? So here's an example where you have to reverse the order of integration. The last 2 are a couple of triple integral problems, right? This one is, I at least give you the form of it, blah, blah, blah. This one I just totally just say, find the volume. What is going to be inside the triple integral to do this? Just 1. I love it. Because remember, the very first thing we did was we took Math 180 integrals and we made them into double integrals. As long as the inner function is 1, it will find the area. In this case, if the inner function is 1, it will find the volume. Maybe.
What would be the limits for?
Well, that's the whole point, right? For which one?
For 10.
10 is neat. I like 10. You would like 10, Jeff. So it's got to be below the cone, this.
I understand that.
Where does the cone kind of start? What point? 0, 0, right? Because then the height would be 0, correct? And as you move up, it's a cone, and because the square root of those things are basically come out to be first dimension, so there's going to be straight sides to it, yes? Okay, I like it. So it's a lot like that paraboloid problem we did earlier. If I go up a little bit, what's happening to my region of input? So if I just get the tip of the cone, yes? The part that you and Jeff would always bite off when I got an ice cream cone, yes? The little tip on the XY plane, the region in the XY plane is just 0, 0, yes? The minute I move up on my cone, what's the cross section going to look like? And then I'm gonna live in the, so my area in my xy plane grows. So my area in my xy plane is determined by how far up on this I go. How the shit do I figure out how far up that cone I go? Well, I don't just have a cone. I got some ice cream, yes? The paraboloid. With me? So it's got to be above the paraboloid and below the cone. So if I cross-section this, it's got to be above the parabola and below the cone. So it's got to be in here. Yes? Yes.
Do we assume that the z values start from 0 and go positive direction?
Well, the z values have to start at 0. I'm not assuming anything. Could I possibly get a negative value for z here? Nope.
So are we finding like the area like in between the cone and the parabola?
Yeah, the volume
Like that little
above the paraboloid, below the cone.
Okay.
Yeah, so that
Little piece.
part around it. Yes. This is a gross picture, but to be honest, this picture gets a lot of the stuff done that you need done. So, first off, which plane, obviously, should my dA live in? XY. Yes, because my z's are going between two well-established functions, yes? How did I determine on the problem we did earlier, the paraboloid problem, how did I determine what my radius was for my dA in, I think it was the XC plane? How did I determine that?
The top circle.
Because I knew it went up to y plus 4, yeah?
Yeah.
Where does this stop? Where does this one go to? Where the two shapes meet. How do you do that shit algebraically? 7 equal to each other. See how far you get. Set each z equal to each other. That will tell you what z will be the top limit on the z integral. Yes? Does that make sense? Love you guys. I look out and see a bunch of me just sitting there going, what are you talking about? Just like before, we found the intersection between, was it y equals x squared plus z squared and y equals 4. I set them equal to each other. That was easy though. That was x squared plus z squared equals 4. Yay! Now, I'm being a lot more evil. Not that much evil. So how the shit do you do this?
Square.
So x squared plus y squared has to equal the square root of x squared plus y squared. So I think you just said what?
Square.
Square. So we get x squared plus y squared squared equals x squared plus y squared. Get in there.
Wait, why is it equal to? Why is it equal to the two?
So I have a paraboloid and I have a cone, and I need to figure out where they meet because that's going to be where things stop. Yes.
Okay.
The earlier example was easier because one thing was just a plane, y equals 4. So I just plugged a 4 in. Now it's this function, so I just plug that function. Yeah. Can anyone see, do you want to FOIL that out? No, neither do I. The answer I want is up here, correct? Yes? Could the answer be 0? No. So x squared plus y squared cannot be 0 where I am interested in. Yes?
Yeah.
So couldn't I just divide both sides by x squared plus y squared? Do you agree I can't do that if x squared plus y squared is 0?
Yeah.
Is that answer related to what I need to find?
No.
Do you agree that x squared plus y squared equals 0 is an answer to this?
Yeah.
Yes, because of course the paraboloid and the cone meet at 0, 0. Is that the part I want? So I say, I'm going to assume it can't be 0 then, because that's not the answer I want. It's on the wrong side of things, yes? So if I assume x squared plus y squared can't be 0, can't I divide by it?
Which means x squared plus y squared equals 1.
Yeah.
Which means it's just
So it's a circle in your xy plane. That's going to be your dA, what the book calls D. Yes.
Okay, so let's say we're taking a test and for whatever reason you can't like puzzle that out in your like mathematically.
This would probably be one where I would give you
Yeah.
the actual like 3D
Yeah.
image.
Well, if I intuitively know that that's going to end up being a circle with radius 1,
How do you mean intuitively?
but I know that the only way to get those two things to be equal to each other, they both have to, like, the only number that works on both sides is 1.
So what's interesting is, here's another way to think about this. Isn't this z equal x squared plus y squared, and this is z squared equals x squared plus y squared, yes? You ready? So if I set these two equal to each other, here we go, z equals z squared, right? I kind of didn't want to go this because this won't always work exactly this nicely, but this is, for this specific problem, this kicks ass, because then if I just subtract z, I can factor, and I get z equals 0, which is not the one I want. That's where they meet at the base of them. Or z equals 1, which is where they meet at the top. That's the one I want. Do you see the analogy between what we actually did and that? I just need to set those two equal to each other.
Because if you actually take a cross section of that, that's a parabola and an absolute value graph. That's what that looks like.
That's what I drew first, and then I try to make it sort of
Yeah, but
3D.
when you do that, they'll meet at 1, because that's when they're both equal.
Exactly.
Graphically.
Yes, because the sides of the cone are just straight lines, slope line.
So when I write an integral, it's gonna be 0 to 1.
All right, so let's talk about what the interval is going to look like now. So, real quick, what did we just figure out? Oh, okay, I know what you mean. We're going to tease dz out of dv, because my dA lives in what plane? I want you to understand, if I would have said that whole sentence to you the first day, so just stop every now and again and realize how much you've gone through and how much you know now that you did not before. Yes. Are you good? Okay. So when I go to set this integral up, I know this is going to be dz and this is going to be dA. So I'm sorry. You guys can tell me every time I do that. So now I can focus my attention on the xy plane. Huh?
And it's a circle, so it can be either way.
Yeah, this is 1, 1, negative 1. So you start to realize this is very similar to the problem we did earlier with the paraboloid. It seems like maybe eventually I'm going to want to change the polar.
Yeah.
And I'm trying to find the volume, so what's on the inside? 1. So if I just leave this as d, what is my z going from to?
0 to 1.
No.
Square
It's going from this wall to that wall.
X squared plus y squared. So
Yes, it's going from x squared plus y squared above the paraboloid, below the cone. So I basically gave that away. Above the paraboloid, below the cone. So it's got to be between those two, yes? Okay. And again, if I gave you this on the test, I would probably give you the 3D image, because then you can kind of track it. Okay. I'm going to leave this alone for now. Maybe, remember the one we did earlier where we wrote it with XY coordinate system and then we changed to polar? Do you all agree I'm probably going to want this to be in polar coordinates? So I'm not going to set this up yet. I'm going to do this internal integral and then I'm going to change to polar. Yes? How do I do the internal integral? It's just a 1, so yeah, top minus bottom. Good old F top 2, right? Fundamental theorem of calculus part 2. Let me do this so it's just set up, ready. Now, does anyone have a preferred way to do this? dy dx? Okay, sure. So what is x? Well, okay, sorry. Jeff, you forgot what you were just saying. Now I'm going to change it to polar. So now when you change it to polar, my picture's already drawn for us, right? Whenever you have a nice circle like that, it's silly. R equals radius. Theta goes from 0 to 2 pi. Yes? Just be careful. Not every time is it going to be a complete circle. So then, all right, just to give away a little something. I could give you a problem where I don't have a complete circle and you have to figure out what angles it goes to. Sorry. It's not as hard as it sounds, but just know ahead of time. It's only 0 to 2 pi here because it's a complete circle. What if I don't want to give away the game. We did a problem like that though, didn't we? If I had something here and it had to go here, and I would make this line something that lines up with something you should already know, then you can figure out what the angles are, yeah? I know we did a problem just like that. So I got you ready for that. So if I change this to polar, what does the inside become? Yep.
Oh, did you spend the R?
Nope. R minus R squared.
Right.
What's dA?
R?
R theta. There you go. You don't have to say it like a pirate, but if you don't, you don't make sense to me. And now it's easy. This is the beauty. If something makes sense in polar, it's going to be almost silly how nice it is. What makes sense in polar is any region that's got some kind of circular motion to it, yes? So some kind of, something that's curvy, not straight. So this would go from 0 to 1, and this would go from 0 to 2 pi. Yeah, and then that's just polynomial, I don't care. Do you see how I didn't have to know at first that it was going to be polar? I kind of worked with it and then I went, oh shit, polar would be good. Do you see how I didn't say a word about polar in the problem? Okay. So next time I'll have the answer key for that practice test. Is it that's fast time, I'm sorry.
I just want to make sure what 15.6. 14. Oh, I'm sorry. 14.7 through 15.6. So
It was 14.
I think you have it on website, right? The one that's on website.
yeah, it's not on website.
Sorry, man. Give me a second. I think it's just one section. I think it's just
14.4. 15.4 was
14.8. Oh yeah, and 15.4. Yeah. Yeah. Thanks, guys. Yes.
Do what now, sorry?
Turning it in.
the revision. Yeah. He was saying that is 14.8 and 15.4.